Good morning, students. I am Navdeep Dhaliwal, faculty of RA College of Engineering and IT, Electronics and Communication Department. Today we will discuss about MTI radar system. So these are my session outlines. So today I am going to explain moving target indicator radar. So basically in this session I will be explaining block diagram of MTI radar system. Then I will explain you how MTI radar system functions, and then after I will explain in MTI radar system how delay line canceller that is significant and how it is identify motion of objects, and then I will explain blind speed in delay line canceller response in with respect to MTI radar system. So basic block diagram is bisected into two parts. One is transmitting section and another is section is receiving section of MTI radar system. Now see, in transmitting section, video input signal is generated by a continuous wave oscillator, and that has been given to power amplifier with respect to pulse modulator. Pulse modulator is having fixed pulse frequency, which is what getting repeated with respect to time, and during this pulse only we give signal, and that signal having frequency that is ft. So ultimately what exactly the case which we do is we send signal by transmitting section with frequency ft, and will be having target which is in motion, and based on motion of target will be receiving signal that is having frequency ft plus fd. So ultimately here the frequency fd, that is frequency drift, which is happening because of motion of target. Now here when we talk about this MTI radar system, all we need to focus on what will be the duration of signal transmitted from transmitter to receiver by this receiver. So once we calculate that duration, we will be able to calculate range when the signal traveling from transmitter to target and then to receiver, it will be traveling by distance 2r. So based on time delay we can able to identify range. Now to calculate this frequency drift we need to use Doppler effect. So now by using Doppler effect we will be able to calculate motion of target. Now here I will explain what will happen over here. Now see, if target moves toward to radar system, then the reflected signal frequency will be f node plus ft, and if target is moved far from radar system, so in that case reflected signal from target that will be having frequency f node minus fd. Now if I say velocity of target is vr, so that velocity will justify what will be the frequency drift. If target is moving towards radar, in that case frequency will be added with transmitted frequency by this radar system. If target is moving far from the system, in that case frequency will be subtracted, and that frequency that can be identified by fd, that is Fd is equal to 2 Vr divided by lambda. Here lambda is operating wavelength, Vr is velocity of target, and Fd will subtracted or added, that depends on which direction target is moving. So ultimately our agenda is to find out what is drift frequency. Once we identify drift frequency, we can able to identify motion of target. So ultimately in receiving system is having delay line canceller. That delay line canceller that will identify this drift frequency Fd, and once it identifies that drift frequency, it will be able to identify motion of target. So a fixed echo signal is continuously received by MTI radar system, and now if we see new signal with respect to fixed echo signal, so then we will observe that there is some target fixed signal that is usually received by MTI radar system. Once target is entering in vicinity, there will be new signal. Fixed signal will be already there, but new signal will added with fixed signal, and that difference that we need to identify. So to identify that difference in MTI radar system, at receiver side there will be delay line canceller. So in receiving circuit there will be delay line canceller. So the input that we delayed by pulse repetition frequency time period, and that is what we are getting into subtractor, and one is directly given to subtracted and one is delayed by, and the difference that will be our output, which is identifying object or target which is there inside. Now here one thing that we need to understand, which is when we see frequency response of delay line canceller, then the frequency response will be like this diagram. Now if you see response of delay line canceller, that is minimum at amplitude 0, so at this frequency there will be blind speed. Reason is response of delay line canceller that is 0 or minimum. The delay line canceller cannot identify object which is there at echo signal vicinity. So if Fd is associated with blind speed, then delay line canceller cannot give response. So that's why speed associated with target is called as blind speed. So what we can do, we can add multiple delay line canceller with different frequency responses. So if we add another delay line canceller with another frequency response, so in that case we can avoid blind speed.